All right, so today and on Wednesday, we're going to talk about the idea of what's referred to as solving triangles. So, all we mean by solving triangles is that we're going to find all the missing sides and angles. Earlier in the semester, we talked about solving right triangles. So this is just an extension of that if we don't have right triangles to start with. So if we look at some of these problems here, I know this one just says find AC, but we're going to talk about how we solve the whole triangle, if you will. So when we have, notice that this angle, it's not too hard to figure out what angle C here is because we remember that the angles in any triangle have to add up to 180 degrees. So to find the measure of angle C here, all I would need to do is take the 180 degrees and subtract off the 118 and subtract off the 22. So I believe we get, what, 40 in that case? If I did my arithmetic correctly. So this is just a way to use the knowledge of already what we know about triangles, that all of the angles are going to have to add up to 180 degrees to figure out that third one. But the hard part in this particular problem, of course, is to be able to figure out the other two lengths of the sides, because when we were doing solving right triangles earlier in the semester, well, if we had a right triangle, we know that if we have an angle over here, theta, and I know, say, x and I know y, then I could do the tangent of theta would be x over y, because I have a right triangle in that case. Notice in this particular example that we're working with, I do not have a right triangle at all. None of those angles are 90 degrees. So this knowledge that we had with right triangle idea is not going to be very helpful for us in this particular example. So there must be another way to do this, and there is, and it's referred to as the law of sines. So let me write that down. All right, so before we do write down what the law of sines is, let me draw a picture so that we can figure out the pieces that we are referring to here. So if I have a triangle, and I'm going to use the same, it doesn't really matter what letters where you put them where. What matters is consistency where you're going to put the other letters. So if I have A, B, and C, usually, I know this particular worksheet that I'm using here doesn't, but usually you'll see the A referred to as alpha, so I don't have to write measure of angle A every single time. You'll see the B referred to as beta, and you'll see the C referred to as gamma. So those will be the three angles. So the alpha again corresponds to the A, the beta corresponds to the B, the gamma corresponds to the C, and then the side that's opposite each of these capital letters we'll use as the little letter. So the side that's opposite angle A, we're going to have little a. The side that's opposite angle B, we'll use little b. And the side that's opposite C, we'll use little c. Now, the reason why we use the opposite side to make those labels is because it's hard to use one of the sides and label it A, because there's two sides that are connected to A. But this third side certainly is not connected to A at all. So if I call the third side A, I'm not confused at which side that I'm calling A. It's the one that's the opposite from A, across from A, if you will. And then the same thing with B and with C. So we will use, as I'm writing up problems, as I'm posting worksheet answers, as I'm doing videos and posting them on YouTube, I will use this convention with labeling my side. So if I have an angle A, the side opposite will be little a, and then the angle I'll refer to by alpha. and then so on down the line. So here's how you use the law of sines to relate these particular values in the triangle. So the law of sines says that if you take the sine of alpha and divide it by little a, that has to be the same value as if I take the sine of beta and divide by little b. And it also has to be the same value as if I take the sine of gamma and divide it by little c. All three of those ratios have to be equal to each other. Now, at any given time, if we're using the law of sines, we're going to use two of them set equal to each other. Which all this means is that we can use any of the two at any given time and make it work for us. So let's go back over to our example. Notice now we have, make this a little bit bigger. We have this angle is 40 degrees. So I already know this number, the 24, that would be our little c. And I know the 40, that would be our gamma. I know those two pieces. This particular problem is asking us to find AC. Well, AC is this segment here, which is opposite B. So I would call that little b. I don't know what little b is, but I do know its angle that's opposite. I know that it's beta. So if I want to use the law of sines to help me solve for b here, the equation that we would use would be, again, I would use sine of beta over b is sine of gamma over c. I'm using the second two ratios. Okay. And I can plug in information that I know. I know that beta is 22 degrees. I don't know what b is. I know that gamma is 40 degrees, and I know that c is 24. So we can cross multiply here to solve. So I would have, right over here, so a little bit more room, I would have b times the sine of 40 is equal to 24 times the sine of 22. And then I would need to divide both sides by 40. So I would have b is equal to 24 times the sine of 22 degrees over the sine of 40 degrees. And now it's time to use our calculator to figure out what this value is. So let me switch over to a calculator here. So now, of course, I've forgotten what the number was. 22 and 40 over here. So we had four. One thing I should do before anything else, in these problems, your angles are typically going to be given to you in degrees. So before you do anything else with your calculator, you'll probably want to go make sure that you're over in degree mode. So I went to mode and then over to degree mode. Okay, so we had 24 times the sine of 22 degrees, and then divided by the sine of 40 degrees. And we get the 13.9868. So if I switch back over, that was 13.9868. I believe in Hawks it typically asks you to round to 4 decimal places, if I remember correctly. That's what I will ask you to do on different worksheets, is to round to 4 decimal places. So I just have those 4 in there. So again, we use the law of sines to get this equation. And notice the reason why we use this one, it asked us to find the B first. We're going to find the A here in a second. But the reason why we used this one was because I knew 3 of the pieces of information and needed the 4th one. Questions on that part before we find the other side? Okay, well, let's find the other side then. So I have angle A is up here at 118. I don't know little a. So I can set up a ratio with using the law of sines to help us find A. Now, we know B now, so I could use that, but usually it's safer if you use non-rounded values when you can, just for rounding error issues. If you use rounded values and then calculate again and round again, there's more chances for making rounding errors that way. So you could set up a relationship with beta and little b, but since b was rounded, I don't really want to do that. So I'm going to use the c, the gamma, and the little c. So using the law of sines again, we would have sine of alpha over a is equal to sine of gamma over c. Again, with that law of sines equation that I wrote up to begin with, it had 3 different pieces. You get to pick out any 2 at a time that you want, and it still has to be true. So we're going to, again, at any time, we're going to pick out when we know 2 of them, we know 3 of them, so that we can plug it in and figure out the 4th. So our alpha here is 118. I don't know A. Our gamma here is 40, and I know that C is 24. Just like we did before now, we'll cross multiply. A times sine of 40 is equal to 24 times the sine of 118. And then divide by A. Or so not divide by A. To solve for A, divide by sine of 40. So we get 24 sine of 118 degrees divided by sine of 40 degrees. And then again, we can go and put this into the calculator. So let me swap over to the calculator real quick. Now, notice I have most of this already typed in from the previous ones. I'm going to try to work a little smarter and not harder. If I use the second and then entry, it brings up the previous entry. I'm going to scroll over. I need to type in 118. I have to be a little bit careful because if I hit an 8 now, it's going to delete that last part. So I'm going to do second insert up here and type in an 8. Just save me a little bit of typing. If you don't want to do that, you don't have to. You can retype the whole thing. I was just trying to save myself a little bit of typing because I'm lazy. That's what mathematicians are inherently lazy. So here's our last one, the 32.9669. So let me go back over. 32.9669. And we've now solved the triangle because we found the 4 pieces of information that were missing, the 3 pieces of information that were missing in the triangle before. So that's what it means to solve a triangle, is to find all the missing parts. Questions on that at all? All right, well, let's look at the next one. And again, I know this one says find AB, but really I want to solve the triangle. So again, I'm going to change the directions here to solve the triangle. Oops. So right away I see that missing pieces that we have are the angle here at A, which again we call alpha, the side across from A, which we call little a, and the side across from C, So we'll call little c. So those are the three pieces that we're missing. Just like in the previous problem, I think the easiest thing to find is the alpha, because I'm given two of the angles. I'm given the 53 and the 44. So to be able to find the alpha, I just have to take the 180, subtract the 53, and subtract the 44. Now 53 and 44 together make 97, so if I subtract that, we get 83. I'm doing my arithmetic right in my head. I'm trying not to switch back over to the calculator more than I have to. All right, so now that we know this angle, the alpha, we can certainly find A, and then we can find C using the B as well. So it doesn't matter what order you do it in as long as we get all three. Since I just found the alpha, let's go ahead and do the A at the same time. So according to the law of sines, I would need sine of alpha over A is equal to something, either with the beta or the gamma. Well, if I look at my gamma is the one at angle C, I don't know the angle C, or the side C across from it. So it's not really going to help me to use that one right now. So let's use the beta and the B. I know that alpha is 83 degrees. I don't know A. I know that beta is 44 degrees. And I know that B is 7. Cross multiply. And divide. And we get A is equal to 7 times sine of 83 degrees over sine of 44 degrees. And just like before, now it's time to use the calculator to get the approximation. I remember all the numbers. That's the hard part. 87, 83, and 44. 7 sine of 83 divided by sine of 44 gives us 10.0018 rounded to that fourth decimal place. So we said that was 10.0018, if I remember my number correctly. Okay, so far we've found two pieces. We need to figure out the third. So the third is the C that we're missing. So to figure out C, we'll use sine of gamma over C. I need to set it equal to either sine of alpha over A or sine of beta over B. If I use A, I've got a rounded value, and I try to avoid using rounded values to solve for new ones if I can. Sometimes you can't. Sometimes you just have to. But if I can, I like to use the values that were given. So I'll use sine of beta over B. Gamma is 53 degrees. I don't know C. Beta is 44 degrees. And B is 7. Get me some more room over here. Cross multiply. So you get C times sine of 44 equals 7 times sine of 53. And then divide. So we get 7 times sine of 53 degrees over sine of 44 degrees. Go back over to our calculator. And like I said, I use that second entry to bring up the previous entry because all I need to do in this one is just change the 8 to a 5 and get 8.0478. Again, rounding to that fourth decimal point, so 8.0478. And that's our third piece of information that was missing. Any questions on that one at all? All right. Let's do a couple more examples here. Those were all finding sides. Let's see if we can figure out finding some angles here. So let's look at this number 6, where we've got 3 sides given to us and an angle. All right, so notice that in the first step that I did in the first 2 problems, I was looking at trying to find the last angle because we were given 2 of them. And notice we're not given 2 in this case. So in this one, we're going to need to find an angle first. What I would suggest doing, and just getting in a habit of doing this, is when you're trying to find an angle, find the biggest missing one first, okay? So the way you find the biggest one is, of course, the bigger a side is, the bigger the angle is opposite it. So we know that this gamma here is going to be bigger than this beta here. Okay? Because the 21 is bigger than the 16.1. So that means to get this to be 21, this would have to open wider, if you will, than for this one to be at 16.1. Okay? So bigger angles are always opposite bigger sides. And just in general, if you're going to solve for an angle, and you can, I would always solve for the biggest one that you can find first. It's just going to help you out later. Okay? All right, so if I want to find the gamma first, well, this is my C. This is the only angle that I'm given. This is the alpha, and this is my A. So we'll use sine of alpha over A is equal to sine of gamma over C. Pardon me. I know my alpha is 88 degrees. I know my A is 26. I don't know my gamma. I know my C is 21. So 26 sine of gamma is 21 sine of 88 by cross multiplying. Divide by our 26. I guess I could have just multiplied by the 21 and not cross multiplied in that case, but that's okay. 21 times sine of 88 degrees over 26. And just to save me from having to go back and forth, I'm going to go ahead and do the inverse sine of both sides. It's the inverse sine of 21 sine of 88 over 26. So let's go over to the calculator. So we have the inverse sine of 21 sine of 88 divided by 26. I believe I remembered all those numbers correctly. So I just typed it all in at once. So this was 21 sine of 88 on top over the 26, and then I did the inverse sine all the way around it. And we get 53.8233. 53.8233. Oops, hit the wrong one. So our gamma is approximately 52.83. And of course, I already forgot what it was because I messed around with the count of the screen. Was 8233. What was it? What was 82? Whoa. 8233 degrees. So we found our gamma, and now we can find beta. You could find beta using the law of sines again, but there's no reason to. Your beta is going to be the third angle in the triangle. So we know they all have to add up to 180. Alpha was 88. Gamma was 52.8233. Let's see. So this is 92. So you would get 39.1767 for our last one. So we found those two pieces of information that were left. Questions on that one at all? All right. Let's see if we can do another one here. Let's see if we can do ones where we're not given the picture to start with. All right. Here's some down here. So sometimes in the problems, especially ones that you'll see in Hawks, you're just given different lengths of things. And so you'll have to start different measures of things, and you'll just have to start finding it out. So let's see if we've got number 11 here. So first thing I'm going to do is just draw out the triangle. Again, where you put these letters isn't as important as long as you know where things are supposed to go. Measure of angle A is 70, so 70 degrees goes here. The length of side A is 25. Again, side A is the one that's opposite angle A, so I'll have 25 here. And the length of side C is 26. That's the opposite. So we have 26 over there. All right, so want to solve the triangle in this case. Notice the first thing we probably should do here is figure out what angle C is, because I know angle alpha, I know angle A, I know side A, I know side C, but I don't know angle C. So again, if we refer to this one as gamma, the law of sines tells us we have sine of alpha over little a is sine of gamma over little c. And then we can plug in the different values. Sine of 70 degrees over 25 is equal to, I don't know gamma, over 26. Cross multiply, 25 sine of gamma equals 26 sine of 70 degrees. Divide by 25. We get sine of gamma equals 26 sine of 70 degrees over 25. So do the inverse sine of both sides. It says inverse sine of 26 sine of 70 over 25. Now it's time to flip over to the calculator. Inverse sine of 26 sine of 70 divided by 25. We get 77.7633. So 77.7633. All right, so there's one angle. Now, this problem actually has something in it that we haven't talked about yet. So let me talk about this, because this one's, you have to be careful when you're using law of sines when you're solving for an angle. So before I talk about that, let's go back up to the problems that we've done before I come back down to this one. Okay. So notice in the problems that we did before, let's go back up to the very, very first one. Notice that in the very, very first problem, we were given two angles and an included side, sorry. That, remember, if you think about that from your geometry class, that's referred to as angle side angle. That was a congruence theorem. Okay? So what this means is, if you think back from the geometry, once you know two angles and the side that's in between them, you know exactly what the triangle is. There's no possibility for anything else. It has to be that triangle. That's it. Okay? Over here, basically, it was a special case of this. We were given two angles and an included side, or the side that wasn't included. But of course, if you're given two angles, you really know the third, right? So you do know two angles and an included side. This is also a congruence theorem. And again, what this means is that if you're given two angles and a side, you completely know the whole triangle. There's no other possibility. This is the triangle that you get. Okay? In this one, there's a couple of congruence theorems that actually go on in here. We were given three sides. That's a congruence theorem. If you know all three sides, you know exactly what the triangle is. Or if you just look at these three things here, you were given two sides and an included angle. That's also a congruence theorem. So the point of all that is, in all of the problems that we did before, the three examples that I've done so far, there was only one possibility that you could possibly get based on the way the triangle was set up for you. Okay? In the first case, you were given two angles and an included side. That's a congruence theorem. In the second one, you were given two angles and a side. That's a congruence theorem. In this one, you were given, you can think about it two ways. You were given three sides, or you were given two angles and two sides and an included angle. Either way, that's a congruence theorem. All right, let's go back down now to the one we were just talking about. If I get to it. Notice in this case, we're given two sides and not an included angle. Okay. Notice that you can rearrange the letters of this thing if you think about angle and side. It gives you a way to understand why this is not true. So this is not a congruence theorem. Okay? What that means is, if it's not a congruence theorem, what that means for our purposes is that we could get no triangles, one triangle, or two triangles. Okay? So anytime you get two sides and an angle that's not in between them, you could get more than one triangle. You might not get any. Now, the not any case is easier to see because right away you'll get an error in your calculator and you won't have any. But the two triangle one to check is a little bit harder. So the way to remember is, whenever you use the law of sines to find an angle first, if your first step is to use the law of sines to find an angle, always check for a second triangle. My pen stopped working for a second. Okay, why is it not working on that spot of the screen? Second. I don't know why it's doing that. I'll just avoid that spot on the screen. This computer's been acting squirrely for 2 days, so I don't know what the problem is. Earlier, on my class previous to this one, it just kicked me off of Zoom. So, anyway. So whenever you use the law of sines, you always check for a second triangle. Okay? So let's talk about how we check for a second triangle. So let's go back up to what we have. We found out, well, they gave us that alpha was 70 degrees and gamma is 77.7633 degrees. From this one, we can find beta. If we add those two together, we get what? 147.7633. So that's going to be 32.2367. 132 is too big. Try that again. It's because it's not 132, it's 32. Sorry. That's better. All right. So this is going to be one of our triangles, and we still have one more side to find. However, there's another way we could have done gamma. And this comes from remembering our knowledge from what the sine function does. And this is stuff that you actually did for solving trig equations. I know that over here in quadrant 1, if I do 77.7633 degrees, if I think about my reference triangle, that this opposite side would help me find my sine value. But there's also a quadrant 2 angle that would have the same sine value, right? There's also a quadrant 2 angle over here that has a reference angle of 77.7633 degrees. So to find this one, I would need to subtract from 180. So here's what we do. We take our gamma. This is how we check for a second triangle. You take your gamma. You see if the 180 minus the 77.7633 will work. Okay, so the first thing you'll do is subtract it from the 180. That gives us what? 2367. Right? Check it with your alpha. Does this add up to less than 180? Well, when we add these two together, we get 172.2367, which is less than 180 degrees, which means there is a second triangle. Okay? Let me go through again why we did this. We found the 77 using our law of sines. But remember, SSA is not a congruence theorem. Okay? It does not completely determine the triangle. We know there's at least one. We're trying to see if there's two. Okay? So the way we see if there's two is that we take the gamma, or whatever angle we solved for, subtracted it from 180, and then check if the two angles here are added together are less than 180. If it's less than 180, there's a second triangle, because now I can figure out my beta. My beta here would be what? 7.7633. Because it's 180 minus the other two. Okay. So this would give me my three angles now. I've got a 70 degrees, a 102, and a 7. This works, right? This could be three angles in a triangle. Just like this could be three angles in a triangle. Okay. So again, the way we always check is take the angle that you solved for, find its supplement, find the quadrant 2 angle that has the same sine value, and check if it works. If when you add them together, you get less than 180, it works. If you add them together and get one over 180, it doesn't work, and you only have one triangle. Okay. All right, so back to solving. After all of this, I've forgotten what the length of the sides are. 25 and 26. There's the picture. All right, so there's one more side to solve for in each of these. So for B over here, which we still need, I would have sine of beta over B is equal to sine of alpha over A. Why is it doing that? It's got a spot in here. It's not letting me write on. Okay, what is going on? Anyway, frustrating. So sine of 32.2367 degrees over, I don't know B, is equal to sine of 70 degrees over 25. Cross multiply. And divide by the B. So I have the B is equal to the 25 sine of the 32 and change degrees over sine of 70 degrees. So, good job for a calculator. So I'm going to use the calculator to get my value, so I don't have to remember what the decimal was. All right, so one of the angles was 70, and previous answer was that angle. So this is the beta we're using. So we want 25 sine of that 32 degrees number. So I'm using that previous answer button again, divided by sine of 70. And we get 14.1913 for your B. So B was approximately 14.1913. So this is, again, one of the possibilities for our triangle. So we found the gamma, we found the beta, and we found the B. So this was one of the possibilities. We still have to do the other one. So to do that in this case, set up the same thing. We'll do sine of beta over B is sine of alpha over A. But in this case, we're going to use a beta value of 7.7633. The other one's still going to be sine of 70 degrees over 25. And then now the solving is exactly the same as it was. So we have B sine of 70 degrees is equal to 25 sine of the 7.7633. And then divide by your sine of 70. And again, this looks like a good job for the calculator. Let's see if I can get back to that 7.76 number. So I'm going to use my second entry button to get back up to where we calculated gamma the first time. There was our gamma, the 77.7633. We found our second gamma by doing the 180 minus that number. So that was our second gamma. So now if I do 180 minus the alpha, which was 70, minus this new gamma, There's our 7.7633 number we're using for beta now. Okay, so again, just going through those calculator steps, this was how we found gamma. That's 77.7633. This would be our check to see if we have a second triangle. This is what I was doing off to the side. I find the second quadrant angle, subtracting it from 180, get 102. If I add that to the 70, we know the other angle is there a possibility for a third angle? And the answer here is yes, because 102 plus 70 is less than 180. So we have a second angle, which means we have a second triangle. So now we can finish off that problem. 25 sine of the beta divided by the sine of the alpha, which is 70. And don't hit the wrong button. We get 3.5938. 3.5938 for our B in that case. So for this one, 3.5938. And so these three, this two with this one, give you your second triangle. So again, the moral of the story on this one is, if you have to solve for an angle, when you're using the law of sines, always check if there's a second triangle. Okay? And again, the way you should check if there's a second triangle is subtract the angle from 180, add it to your other angle, and see if it works. All we did here was check to see if it works. Okay? And it did. So then we did we just solved the triangle like we've been solving the other ones. Okay? So there's just there's just an added step. If you use the law of sines to solve for an angle, check to see if there's a second triangle. That's it. And if there is, just solve for it. Any questions on that at all? All right, I will post solutions to this whole worksheet on Moodle. I will do a video doing a couple more examples so that you'll see another example with two triangles and a couple more examples. I'll show you an example with no triangles to see what the no solution part looks like. I'll get that done this afternoon so you can see those things. So anyway, other than that, I will